magnetic field's direction. Okay, that is clear now. So let us see how the magnetic field depends on the circular loop, and are there various factors depending, like we have converted this straight loop into a circular path. Okay, so is it going to affect the various ways the magnetic field strength also? Yes. So magnetic field strength, it depends on, like, number one, magnitude of the electric current. As I have told you a lot of time, current is directly proportional to B. So more the current, more will be the magnetic field, and less the current, less will be the magnetic field. So here also, if the current value is increased, so we can say the magnetic field lines producing here will also get increased. Okay. So according to the right hand thumb rule, like in this direction, we are going to have the magnetic field. Okay. Like here, like here. And if it is going in the downward direction like this, so it is going to be like this, like this. Okay, जैसे मैं बना रही हूँ उसी direction में move करेगा. Okay, and in the center it is going to be straight line. Fine, students. So magnitude is very important. छोटा करंट दोगे तो मैग्नेटिक फील्ड भी बहुत कम आएगी, तो कम असर करेगी. Even I have done this experiment at my home. What I have done in this straight carrying conductor, and I have connected it to battery. Okay, when I connected it to battery, and because it was straight, so it will produce less amount of magnetic field, as I have told you. So radius is depending, and I have just connected it to battery, so कितना ही current आ जाएगा. That is producing a magnetic field line, and I have just kept a iron nail, small iron nail near to it. Now that iron nail is attracted to it, but when I kept it little bit far, then it won't be able to attract it towards itself. Okay, so here when I have put, like, mold it in the circular loop right now, so at this direction also now it is going to be attracted towards it, though it is just a single loop right now. So here we can say that the radius is also depending. Bigger the circle, like this is the circle, if you are reducing it, it is a smaller circle. So the concentrated field lines are here in the circular small circle. Now the concentration of the magnetic field line will become high. Because the loop earlier was big, somehow it is treated as, like, आप इसको और बड़ा कर दो, so ये straight ही हो जाएगा. जितना छोटा आप circle बनाते जाओगे, so more the concentration of the magnetic field lines will be there. And when the concentration of magnetic field lines is going to increase, so we can say that at this point the strength of magnetic field will also increase. Okay, so here as this loop is big, so at the center we can say that a less amount of magnetic field strength is there. But when we more squeeze it, small it, okay, like this, so it will produce a lots of like the current value is same. So we can say that for that current, big current, this loop is very small. So for this particular loop, there will be more and more magnetic field lines here. More and more magnetic field lines are passing through here. So the concentration of magnetic field lines is going to be increased. Okay, so this is the result as the decreasing of the radius of the circle. Here the radius value is less. Radius is what? You know that in mathematics we have seen from the center point, the distance till the circumference of the circle is known as the radius. And if we are reducing the radius, the magnetic field lines is going to be increased. As you can see here, there is a formula that is written. So this formula, what is it showing? B is directly proportional to the N. N is what? Number of loops. Here N is number of loops. So this is just a one loop. And in the similar way, if we are increasing like this, अगर मैं इसको और ऐसी ही coils बना दूं, then it will known as solenoid. Okay, this is known as solenoid, and that we are going to read in the later slides. So we are increasing. So magnetic field lines is depending directly proportional to the number of coils here. If we are increasing the coils, magnetic field strength is increasing. And in the straight conductor, there is no coil. So accordingly, we are getting a small amount of magnetic field. Okay, now strength of the current, it depends on the strength of current. More the current, more the magnetic field lines, and it depends on the radius. So radius of the circular loop, if this radius is more, because it is inversely proportional, more will be the radius, less will be the magnetic field, and less will be the radius like this, more will be the magnetic field. So all these properties, I guess you get it very clear. Now let us come to the solenoid part.